Okay. So first of all, you've got to be comfortable with story problems because they're going to be tested on, and they're usually, honestly, when you see them, you should say yes, this one's going to be easy because they really are. Okay, so look at number 31 on 2-3. It says the side of a cube measure is 3x plus 2 units long. Express the volume of the cube as a polynomial. So first of all, a couple of things I need to point out to you and remind you of is a cube looks like this, right? A three-dimensional cube. One more thing. A cube has the same length, width, and height because it derives from a square base. Does that make sense, everybody? So if we know that the length is 3x plus 2, we know the width is 3x plus 2, and the height is? So now let's see what this story problem is asking us to do. It says, express the volume of a cube as a polynomial. Anytime you're dealing with this story problem, you're going to hear me say, set up a true statement, and then if you need to solve, do. But this one says, find the volume. Isn't our volume, what's the true statement for volume of a cube? Length times width times height, right? So volume is 3x plus 2 times 3x plus 2 times 3x plus 2. Now it says, express the volume of the cube as a polynomial. Isn't that a polynomial? No, it didn't say that we need to put it in standard form. No. So aren't I done? Yes. So couldn't we also write this as 3x plus 2 cubed? Guys, did we answer the question? The volume of the cube as a polynomial, yes. Was that hard? So our story problem's all hard? No. Now understand though, I might have said, express the volume of the cube as a polynomial in standard form. So you would have set up this, and then wouldn't you have multiplied these two together? Combined like terms and then multiplied it in here. But that should not be hard for us. So we can't just say, oh, it's a story problem, so I can't do it, okay? Now, next thing I want to show you. So, this is a volume equation. I didn't ask you to find the maximum volume, but let me explain something. If I literally had a cube here and I was pouring water in, as we pour in positive water, aren't we getting positive volume? Yes. So we're pouring in positive water, amounts of water, and we're filling up. So now if I was to say to you, find the maximum volume, you could just solve and figure out that maximum volume by graphing. Now don't type this in, I just want to show you. Let's pretend that I graphed and got something that looks like this. Now this is representing volume. So look, as I pour in positive water, I get positive volume. As I pour in more water, greater amounts of water, aren't I getting higher volume? Isn't it making sense? So isn't this going to be the maximum volume right there? Does everybody see? So if I said to you, find the maximum volume, you would just graph it and then say, well, what's that value right there? So let's pretend that that was over 2 up 110. We plugged in 2 amounts of water and got out this much volume, 110 worth of volume. So our max volume was just 110. Does everybody see how easy that was? Does that make sense? Okay, so if I say you find the max volume, graph it and find the max. And then there it is. Okay, cool. So let's look at number 7 on the back page. So it says, this one's super easy. You just got to know what it's asking. It says, the number of bacteria in a fridge of food is given by this equation here. Okay, so that's representing bacteria in a fridge. Now it says over the interval, so for temperatures between -2 and 14 degrees Celsius. That doesn't even really matter. Like, okay, cool, we're only looking at the temperature between those 2 degrees. Does everybody understand, though, that that's not really saying much more here? It's just saying look at the temperature between -2 and 14. That's all we care about. Okay, now it says, at what temperature will the number of bacteria be minimal? Sketch the graph. So everybody, I'm not going to sketch the graph. I'm going to graph it on my graphing calculator and find the minimum, wouldn't I? Wouldn't the minimum be the minimal amount of bacteria? Now I want you to notice something. It's a quadratic. So isn't it going to look like this? So won't this point be the amount of the lowest amount of bacteria? Okay. Go to your calculator, type it in, go to y equals. You're looking at number 7 here, so you can look on your paper. So let's type in x's instead of t's. 20x squared minus 20x, no, yep, minus 20x plus 120. Now understand something, everybody. If we plug in 0 for x, that'll be 20 times 0 squared. Isn't that 0? Minus 20 times 0. So then 0, if I plug in 0, I get out 120. So we need to have our window at least as high up as 120. So go to window. So I hit graph and I can't see it. Oh, I can because my window's good. But if you couldn't see it, you got to go to window and say, I need to make my window y max bigger. 120 was the y-intercept when x was 0, y was 120. So I knew I needed to see high up. So I changed my y max to 150. Now I hit graph. And now we'll do a second trace. Find the minimum. Left bound, enter. Right bound of the min. So our minimum is at 0.5 of 115. So 0.5 of 115. I don't care if you graph it, as long as you understand what's going on. So this is over 0.5 of 115. Okay, now think about it. We've got to answer this correctly here. Wasn't this temperature, and this is the number of bacteria that we see? How did I know that? Because look, T was in the equation, so it wasn't our temperature, the X's. And then what did we get out? Amounts of bacteria. So this is the temperature, this is the amount of bacteria. So now we've got to answer the question correctly. It says, at what temperature will the number of bacteria be minimal? So our answer would be temperature of 0.5 degrees Celsius. Everybody good? I could have asked, though, what's the lowest count of bacteria? And you would have said 115. Does that make sense of the different questions? Not a bad one, though. Wasn't this really just testing? Do you know how to find a minimum? Okay, cool. Okay, I want you to not do this one. I have to fix something. There was something weird last hour with this one. Okay, let's make that a plus sign and see if that helps. Okay. So it says the length of a rectangular prism. So let's look at our rectangular prism. So that means that the length, width, and height are not the same. So the length of a rectangular prism is 2x. The height is 2x minus 1. This one's not on your paper. And the width is 3x plus 1. It says find the maximum volume. So to do that, don't I need to set up a true statement? Volume is length times width times height. 2x times 2x minus 1. Times 3x plus 1. So now you don't even need to multiply that out. I need to know the maximum volume. So won't I, if I graph this, just find the max? Okay, do it. Ready, set, go. Go to your calculator. You can literally just type it in factored form instead of standard form. So go to y equals and type in this and then hit second graph. And then you might have to make your window better. 2x parentheses 2x plus 1, was it? Or minus 1, wasn't it? Minus 1. And then 3x plus 1. Now I know if I hit graph, I don't need to see that high up. So I'm going to go to my window, go to y max, and make it much smaller, back down to 5. Okay, now look. Right here, that piece is the maximum volume right there. So now all I need to know is the maximum volume. So I just need to find the max. Second trace, find the max. Left bound, scroll left, enter. Right bound, enter, enter. My maximum volume happened at negative 0.2 up 0.2. Negative 0.2 up 0.2, is that right? Ish. Okay, so think about this though. So I made this problem up on the top of my head. Volume means if I pour something in, we get volume out. So I couldn't pour in a negative, could I? So this wasn't a very good story problem on my part. My bad. I just made it up on the fly to get extra practice. But we did get out positive volume. So our volume is up at 0.2 at the maximum piece here. Does that make sense? Okay, go to problem number 33. Another type of story problem. Once again, really, they're not too bad. But these are what you will see on your ACT. This is a really good one that you could see. So it says, look at 33 because I don't have the words written up here. So 33 says, you have a block of wood that you want to use to make a sculpture. The block is currently 3x units wide, 4x units high, and 5x units deep. So I'm going to draw myself a picture. So 3x, 4x, and 5x. Now it says, you need to remove 1 unit from each dimension before you can begin your sculpture. So now, before we can begin our sculpture, we're going to have to be subtracting off a unit, correct? That's what it said? So we got to subtract 1, subtract 1, subtract 1 from each piece. So what that means is we were literally slicing off 1 unit here, and then a 1 unit here. We're slicing that off. And now we can actually start. So it says in A, what's the original volume of the block? Before you took off that unit, what was our volume? So what would it be? Length times width times height, right? So the original was 5x times 3x times 4x. Perfect. 3x times 4x times 5x, which equals 60x to the third. Right? Okay, let's answer part B. What is the new volume of the block? Now that we cut off that red piece here, what's our new volume? So once again, what's our statement? Length times width times height. Well, what's the new dimensions? 3x minus 1 times 4x minus 1 times 5x minus 1. Now, we don't necessarily need to write it in standard form right now. Isn't that a true statement? There's my new volume. However, in this next spot, it says, what is the volume of the wood you removed? So the red part's the wood I removed. Okay? Now, you can't just say 1 times 1 times 1, because we don't know, like, you can't look at it like that. So here's how you have to think about it. Think about, how can I find the volume of this red piece? Now, think about it. Couldn't I do the volume of the entire thing and then subtract off the volume of the new piece? Wouldn't that give me the leftover red spot? Does that make sense, everybody? Does that make sense? So my true statement to find the volume of the wood we removed would be take the volume of the original, I'm going to put O for original, subtract the volume of the new, and that will equal the leftover volume. So let's actually do that. Now, are we going to be subtracting this volume from this volume? To subtract a polynomial, you would need it in standard form first. So we're going to actually have to hurry and multiply this out. So why is this a good problem on an ACT? Because they're testing if you know how to do critical thinking skills with volume, and now they're testing to see if you know how to multiply out a polynomial. And then they're going to test, can you subtract a polynomial, all in one problem. So now they can go and cross those, all 3 of those off on their list. So what's a bummer is if you miss one of these, they'll say, oh, they can't multiply and they can't subtract a polynomial. Does that make sense? Okay, here we go. Multiply this out. How do we multiply out 3 polynomials? Multiply 2 together, right? Combine like terms. So let's quickly do this. 12x squared minus 3x minus 4x plus 1. So we need to combine like terms. I'm going to write down here. So 12x squared minus 7x plus 1. And now we'll multiply that to 5x minus 1. Here we go. 12x squared times 5x. 60x cubed, you're right. 12x squared times negative 1 is negative 12x squared. Let's cross that out. Negative 7x times 5x. Good. And then negative 7x times negative 1 plus 7x. Let's cross that out. 1 times 5x is plus 5x. 1 times negative 1 is minus 1. Let's combine like terms now, adding straight down here. So we have 60x cubed, no other x cubes. Negative 12x squared minus 35x squared is minus 47x squared. Plus 12x is minus 1. Now that was just the volume of the new, wasn't it? So now we're almost done. The volume of the leftover was the volume of the original, which was 60x cubed, minus the volume of the new. So it's minus all that stuff. You've got to use parentheses. So you're subtracting off the entire volume. So now we're testing, can you subtract two polynomials? Anyone have a suggestion on how I should continue this correctly? I like that idea. Let's distribute -1 through. -1 times positive 60x cubed, negative 60x cubed. -1 times negative 47x squared is positive 47x squared. -1 times positive 12x is minus 12x. -1 times -1 is plus 1. And then that did not affect this, did it? So now we can combine like terms. So this is 60x cubed minus 60x cubed. Isn't that gone? And then, so the volume of the leftovers equals that. 47x squared minus 12x plus 1. That one was probably one of the harder ones. Yeah. Okay. So, I want you to now take some time, cross out problem 29. Also, cross out problem 8 on the back. And then I need you to finish up the rest of those story problems right now. And then have me check them off, and then we'll hand it in. So think a little bit, you guys. A lot of these are really, really easy. So just think a little bit. And then if you need help in direction, ask me. Ready? So, couple things to understand. What have we been doing in this unit? We've been getting really comfortable with polynomials in general, right? We've done end behavior of polynomials, number of turning points. We've done increasing and decreasing of all different types of polynomials. We've then found max and mins, and then we've solved by factoring. Factoring by grouping, right? And factoring out greatest common factor to find the zeros. So we're just getting more and more comfortable with polynomials in general that are not just degree 2 in this unit. So what we're doing today is 2-8. We're going to be modeling polynomials in real-world settings. Now think about it. In the real world, if you become an engineer, you're going to be using a calculator to do all your calculations, right? So in like your company's going to want you to use a calculator so that you're 100% accurate as an engineer. So we're going to be using our calculator for anything that we can. So today is just going to be all calculator based. Very easy, and it's really cool. So polynomial functions can be degree 0, degree 1, degree 2, degree 3, and so on. We know that. We've seen polynomials of any degree. Now it says right here, you can use polynomial functions to model many real-world situations. The behavior of the graph of a polynomial functions of different degrees can suggest what type of polynomial will best fit a particular data set. So everybody look right here. We have some xy points. Do you see how I have 0, 10.1? Look, I've graphed those points down here. So over 0 up 10.1. Then I'm over 5 up 2.8. I'm over 10 up 8.1, and so on. Do you see how I plotted those points? Now let's look. Does those points match the line? Those points are not linear. So do you see how we know for a fact those points are probably not coming from a linear fashion? They're not coming from a line. Now look, if I draw in a quadratic, do you see how a quadratic is a better fit than a line for those points? But it's still not a perfect fit. But it's better than the line, isn't it? Well, now look, when I draw a cubic, isn't that a perfect fit? So that means that these xy points came from a cubic polynomial. Now, if I said to you, what polynomial did those points come from, you would just then use your calculator to do it. Okay, and I'm going to show you how to do that. So everybody, here's our first example. It says, given these xy points, give me the equation of the polynomial that generated those, right? So think about it. If we have an equation, can't we graph it? And that's where points come from. So we're just using our calculator to figure out what was the equation that gave us these points. So we have xy points, xy points, xy, xy. Now everybody pull up your graphing calculator. Our calculator will tell us the answer to this. Couple things we need to do though, however. So we're going to get out of here. So the first thing we need to do is turn our diagnostics on. So everybody follow me through this, because if you get behind, then you're going to slow us all down. So everybody hit second, 0. We're going to the catalog. If you reset your calculator, you have to retype this in every time. So we're going to scroll down to the word diagnostics on. We're going to diagnostics on, so go to the D's. So look right there. Diagnostics on. Hit enter. Okay, hit enter, everybody. Now hit enter. So it's done. Everybody's good. Now I'll tell you what that means in a minute. Now what we're going to do is we need to tell our calculator what XY points we're dealing with here. So now this is where you'll have to go. You're going to have to remember this for the test. So you're going to hit your stat key. Stat. And then we're going to go into edit. Stat edit. Now in list 1, does everybody have a list 1 and list 2? Couple important things to point out. If you go up here and hit delete on accident, you're going to delete list 2. It's got to be list 1 and list 2. If you unaccidentally delete list 2, list 3 will shift over and then it's going to say error. So you would have to reset your calculator, like a brand new calculator. You all know how to reset your calculator, right? Second plus sign and then go down to reset. That's how you reset it. And then it's like a brand new calculator. You go through the motions of resetting it. Okay, stat edit. Now you can clear out a list. So let me show you how you do it. Do you see how I'm up here highlighted in list 2? I want to clear out that entire list, so I hit clear. Notice nothing happened. I've got to scroll down, and yes, now it's recognizing I'm clearing out that list. So look, I'm going to clear out list 1. I've got to highlight list 1, hit clear, not delete, scroll down. Okay, in list 1, type in your X values. So your X values were 0, 1, 2, and -1. In list 1, we type in our X values. 0, enter. 1, enter. 0, 1, 2, and -1. Yes. Okay, well, I'll come help you in a second. Did you try resetting your calculator? Okay, there was somebody else that had that same problem. I think I know how to fix it in a second. Oh, let's see, actually, stat. Go to this, hit stat, and then go down to number 5, and hit enter. And then now go back into stat. Okay, now in list 2, type in the corresponding Y values. They've got to be the correct X and Y values that match up. So -3, -1, 5, and -7. -3, -1, 5, and -7. Now notice something. Did I have to type these X points in order? No, our calculator will do it for us. So it's so nice. We don't even have to think. Does that make sense? You don't need to put them in order or anything. These do need to match up though. Okay, now what we're going to do is we're going to hit stat. We've already done edit. But now we're going to go over, we've got to do some calculations. So we're going to go scroll over to calculate. Now look, do you see it down here where it says linear regression line, quadratic regression line, cubic regression line, quartic regression line? We don't know if it's linear or quadratic or cubic or quartic, so we're going to test this out. Let's try linear first. Everybody hit enter. Now, everybody, depending on how advanced your calculator is, some of you, I hit enter and I'm there. Some of you might have to enter through a few things. So enter till you get the same screen as me. Some of you might have to enter through if you have a way advanced calculator. Okay, is everybody at the same screen? Then your diagnostics you didn't turn on. Okay, well yeah, so your calculator's too old to have that. Oh my gosh. Recording. It gives you, a line is AX plus B format. A would be 3.8, so that would be 3.8x minus 3.4. Does everybody see? But now here's the thing. We could write out a line, but we're going to look at R squared. The R doesn't mean anything to us. We never look at R. Only look at R squared. Well, R squared is the regression line. It tells you how the percent of a perfect fit this line is for that those set of points. So everybody, it's a 0.96. That means it's a 96% perfect fit. Not a bad fit, right? 96%, pretty dang good. But let's see if there's better. So hit stat, go over to calculate. Let's try quadratic and see if it's a better fit than a line. Hit enter. Some of you with an advanced calculator will need to enter through a couple things. Now look, R squared is 97% perfect. That's better than a line, right? Well, let's test cubic. Stat, calculate. Let's all try cubic. r squared is 1, that means it's 100% perfect fit. So we're going to use cubic because it's a perfect fit. So we would now write out y is equal to x cubed, and then what was the next coefficient? What was b? So minus x squared, and then what was c? Plus 2x then, and then what was the last thing? Minus 3. Do you see how now there's the equation that gave me those points? Cool. What? Okay, let's do number 1 on the worksheet. Here we go. Go to number 1. It says, find a polynomial function whose graph passes through these set of points. Okay? So everybody go to your calculator, go to stat, into edit. Now once again, you can clear out those lists. Go up to the L2 and hit clear, scroll down. Go over to L1, hit clear, scroll down. So we're doing number 1. So our x values go in list 1. So 4, enter, negative 3, enter. 4, enter. Type in negative 3, enter. Make sure you don't type in a minus sign on accident. That'll be another error. Negative 1, enter. And 13, enter. Are my x, y points lining up? Do I have anything extra typed in? No. So we're good. Everybody good? So now stat, calculate. Let's try a line. Let's try a line. Enter through. R squared is 1, so isn't a line a perfect fit for those 2 points? So we would say the equation that created those points is y is equal to negative 2x plus 7. Now, before you learned how to do this, you should have been able to do that by hand, which wasn't this way easier? On your ACT, you'd want to use this method, because then you know you got it right, because your calculator did it for you. So what I've seen on an ACT is they say, given these 2 points, find the slope. So you could do it by hand, but you also could quickly type it into your calculator, and then you'd say my slope, well, this is my equation, so my slope is negative 2, isn't it? Does everybody see how I didn't even have to think, and I know I did it right? That's worth it to me, and it's quicker. Okay, cool. So that's just how it is. Yeah. Okay, number 8. Let's do number 8. Everybody. Here we go. Go to stat, edit. In list 1, type in your x values. I'm not going to clear this one out. I'm just going to type over them. So 0. 2, I'm typing in number 8. Negative 1 and 3. In list 2, 9, 21, 0, and 36. Now stat, calculate. I'm going to try a line. Enter. Now that's 0.96. That's a 96% perfect fit. Not bad, but let's see if there's better. Trying out quadratic. 0.98, 98% perfect. Let's try a cubic. And a cubic is a perfect fit, looks like. R squared is 1. Oh, yep. All right, sweet. So we have y is equal to x cubed minus 2x squared plus 6x plus 9. There is the polynomial that gave me those points. Okay. So do 1 through 8. Ready, set, go. Get help with the x, y points that are not, cool x, y points. Now they're giving us ones that are used in real world situations. So this is actually where it's kind of cool, because what would happen was this company, for example, this is world gold production. So this company produces gold in millions of troy ounces per year. And so what happens is this company could hire you as a statistician in the real world. So let's say you're a statistician. They obviously keep records, so they know that this year in 1985 they produced that many millions of ounces of gold. In 1990 they produced that many. In 1995 that many millions of ounces of gold, and in 2000 that much. So what they might hire you to do is come in as a statistician, and they say to you, here's our information. This is what we produced in these years, this much gold. Now based on that, can you tell me what we can predict the company's going to produce in future years? Does that make sense? So what you would need is an equation, because if you have an equation, can't I plug in any value for x and find out how much comes out? So what? Let's write an equation. So literally, you'd be hired making the big bucks coming in as a mathematician to just type this into your calculator. So you'd go to your Oh, but here's one more thing to read. It says, let X be the number of years after 1985. So how many? This is X, this is Y. How many years after 1985 is 1985? 0. How about 1990? 5 years after 1985, 10, 15. So we've got to use the correct X value. So go to your calculator. We're doing number 9. Type it in. Go to Stat Edit. And list 1, type in those X values. So it was 0. Now here's the other thing. You would not know, you don't know if this is happening. So have they been producing gold in a linear fashion, or is it more quadratic where it was going down and then back up, or is it more cubic? So let's test this out. So stat calculate, do the linear. Has the gold production for this company happened in a linear fashion? R squared is 0.88. Yikes, that's terrible. It has not happened linearly at all. Stat calculate, let's try quadratic. Still not the best. 0.93. Still not very good, really. Calculate. In the real world, you probably wouldn't use anything under 0.99, just saying. And then, because you want to be pretty accurate. Cubic. Perfect fit. R squared is 1. Now look, there's decimals, but think about it. In the real world, math isn't going to come out nice and gorgeous, right? So that's okay. Just write out all the decimals. You will want to write out all of the decimals so that you can make sure to get it right. So y is equal to 0.038. It was x cubed. And then minus 0.956 x squared was 8.01x. And then plus 49.3. Now this is the equation that matched this data that this company gave you. So now can't we use that to now answer their question? So this would be problem 15. So that's what this company's hired you to do. Go to problem 15. They say, okay, now based on our information, let's pretend it's year 2000. Let's pretend this is the current year that we're on. They're saying to you, how much do you think our company is going to produce by 2010? Well, let's see here. So 2010. So what can I type in for X here? What would be the correct X value if I'm trying to find 2010? 25. Now why? Because it's years after 1985. So everybody good? This is 25. So now all we have to do is say, what's the function when we plug in 25? You literally now go back to your main menu and just type in using parentheses. Plug in 25. Using parentheses. And typing in all of the decimals. It'll surprise you if you're like 1 decimal off of how much different your answer comes out. Okay, so you would type that in. So how many troy ounces, millions of troy ounces of gold will they predict to produce in year 2010? So if you type that in right, you should get 245.8. Does everybody see? So now you can say to this company, okay, based on your previous records, I predict that if things go the way that they've been going in the past, so many years, 10 years, looks like by year 2010, you're going to produce about this much gold. And then all of a sudden, you just made a buttload of money off of something very easy, but they're not going to know how to do it. Does that make sense, everybody? So it's kind of cool. This is like in the real world setting. Now, it asks you on 15 to also find, so look at number 15, it also asks you to find 2020 and 2025. We get the picture. We found this one's good enough. We get the picture. So, what I want you to do is problem number 10 right now. Ready, set, go. Everybody figure out the equation to number 10. There's a reason I'm having you do it. Ready, go. Did you all notice that? You got to watch out for that, because what does that mean? Well, maybe it means 0, but with these, we're not graphing this. So, yeah, if we were graphing this, we're going to call it 0. But we're not graphing this. We've got to be really exact with these real-world problems. So what does that really mean? That means 1.33, E means times 10. That's not an X. That's a times 10 to the negative 4. So what does that really mean? Well, that's a scientific number. We like to have real, like just numbers, not scientific numbers. So we'd move it 1, 2, 3, 4. So what we're going to write is, because we've got to be really exact, 0.000133x cubed. Then the other variables, the other decimals didn't have an e. So we just have to watch for those e's though. Does that make sense, everybody? E means times 10 to whatever whatever exponent, and then move your decimal. And then you would have your minus 0.0105x squared plus 0.3617x, then plus 74.7. So now that we have that equation, go to problem number 16. And it says, okay, estimate the life expectancy for women born in 1986. Now, what I want you to do on 15 through 18, do you see how it's going to have you do it 3 different years? If you understand how to do the first one, don't you understand how to do the second one and the third one? So why do it 3 million times? Cross out the second 2 on all of those. So you'll just do the first year, because if you know how to do the first year, you know how to do all the years. Does that sound fair? Now, I want to point something out to you. You really need to watch. I didn't say this hour, but I need to, because otherwise you're going to get confused. So look, now this company wants to know how much gold was produced in this year, which was in the future. Now, guess what has truly happened in the past? So there was a company that, for example, let's say this company opened in 1965. Well, their factory burnt down in 1985. So and back in the day, they used to keep records on paper, right, in their company. So all of their records are gone down the turlet, okay? So now the problem is they want to know, they come to this statistician and they say, well, we only have records starting in 1985, but we opened in 1965. But between there, all of my records got burned down. I need to know how much gold we produced on year 1. I want to know how much we produced on year 1. So in 1965, how much gold was produced? Well, how many years, what would our x be for this one? Negative 20. So we can go back in time now and say, well, based on your gold that you produced recently, I project that back in the day, you started making about this much gold. Does that make sense, everybody? So you plug in negative 20. Just because you plug in a negative doesn't mean it's going to be negative. It's still going to come out positive. All good? So you can go back in time, too. Okay, cool. What I want you to do is finish the worksheet. That's the end of the lesson. But cross out problems 20 and 21. And then only do those first ones on 15 through 18. Just do that first year on 15 through 18. So let's see if you can get done in class. No, do 22.